Okay, so in order to solve equations with fractions, I could deal with the fractions if I were comfortable with them, right? The majority of us are not really comfortable with dealing with fractions all throughout an equation. So you know how with an equation, if you do something to the entire equation, it remains the equivalent, it just looks a little different? So what we can do is we can figure out something that we can multiply by that will allow us to eliminate the fractions, which then give us a regular equation that's easier to solve. So the way we do that is we look at our denominators, and we want to come up with a common denominator. And it seems like every time I ask that question, that everybody wants to go with the smallest number. Okay, that would be a least common denominator. What I want is the greatest common denominator. Because the goal is to multiply the entire equation and get rid of my fractions. If I don't use a large enough number, my fractions are not going to disappear. Okay, so I want to focus on my denominators only, starting with number 1. What are my two denominators? 5 and 60. So I want a number that both 5 and 60 can divide into, but that's big enough for both 5 and 60 to disappear with. So 5 would be my least common denominator, but I don't want that. I want my greatest common denominator. What would that be? 60. Okay. How do you know? This is what I generally do. I usually look at the largest denominator, and then I say, okay, does every other denominator divide evenly into that big number? If it does, then I can use that. If not, then I'll have to think a little bit further. But in this case, my largest denominator is 60. 5 does divide into 60 evenly. So what I want to do is, in order to get rid of my fractions, I want to take and I want to multiply this entire equation, okay, every piece of it, by 60. Where I have some people mess up is they multiply all the fractions and then leave everything else. That's not how it works. If you're going to multiply an equation, you have to multiply every single term in the equation. Okay. Terms are separated by plus signs, by minus signs, and by equal signs. Okay. Not by multiplication and division, but by plus, minus, and equal. So how many terms are in the parentheses in question number 1? Look how that add. 3. I've got 1/5 m, I've got 1/60th m, and I've got 1. So I have to multiply all 3 of those terms by 60. If we're not comfortable with multiplying fractions, I can show you how to do that in the calculator. Okay, but here's how we think about it. Let me erase. I'm going to start, and I'm going to take 60, and I'm going to multiply it by my fraction 1/5 m. Everybody ready? So this is how you do it. You always look at the denominator. The goal is to make this disappear. A denominator, to make a denominator disappear, what number does it need to turn into? What number do we not have to write as a denominator? 1, right? So as long as I can turn that 5 into 1, I'm good. So here's where we do. I want to ask you, how many times does 5 divide into 60?
8.
Bigger. 12, okay? So if I were to take and divide both of these by 5, that 5 turns to a 1, right? Which means it basically disappears as a denominator. And that 60 is going to turn into 12. And then what I do is I multiply that 12, that leftover part, by everything else that's left over. So 12 times 1 times m, which is just going to be 12m. Okay. That's how I think about it. Now, some people like to do just regular old multiplication with fractions. They like to multiply at the top and multiply at the bottom, and then divide it out, which is still going to give me 12. Okay, so that's whatever you're comfortable with. Also, if you have a calculator or you're going to use my calculators, I can show you how to do the fractions in the calculator too. Okay, so there's options here. Is everybody okay with where I got 12m from? All right, so that's what I'm doing is I'm just going to take and draw. I'm going to take and multiply each term by 60. And so to do that, 1/5, 60 times 1/5 m is 12m. Then I'm going to bring down my equal sign. And then I need to take that 60, and I need to multiply it by 1/60m. 1m. Do I have to put the 1 in front of that? No. Am I finished multiplying? No. Okay, I'm going to bring down that plus sign. And then lastly, I have to take that 60 and multiply it by 1. Now, there's no fraction to get rid of, but I still have to multiply it by 1. And 1 times 60 is just 60. So all I did was multiply to get rid of my fractions. I now have an equation that I can solve, so take a minute and finish it. And yes, it's going to give you an ugly number. It's not a nice, neat, even number. It's going to be a fraction. And not a three fraction. If you guys want to borrow a calculator, go grab one. They're right up there. And I can show you how to do the fractions in that calculator if you want me to. All you got to do is let me know. I'm going to subtract my 1m over to my 12m, leaving me with how many m's? 11. And then I can divide both sides by 11. Does 11 divide into 60 evenly? No. Do 11 and 60 have anything in common that I could simplify? No. So I'm just going to leave my answer as that ugly fraction 60 over 11. If you want to change it to a decimal, you're welcome to. But that just requires more work, so why do that? Make a little bit of sense? Go ahead and try 2 then. Look at your denominators. The first thing you're doing is figuring out what number you want to multiply by that would make both x over 7 and 2x over 63 turn into something that are not fractions. Because if we can get rid of the fractions, we can solve the equation much easier. Remember, it has to be at least as big as the biggest denominator. Start by focusing on your 2 denominators. Denominator and try to decide what to multiply by. So you want to use the greatest common. So you have to at least start with the biggest. What's the biggest? What is the other denominator divided into? People just kind of stare right now. So let's do this one. What are my 2 denominators?
7 and 63.
7 and 63. And again, you want to use your largest denominator, the greatest common denominator, not the least common. So what's bigger, 7 or 63? 63. So I'm going to start with that one. And I'm going to ask myself, does 7 divide evenly into 63?
No. I mean, yeah.
It does, doesn't it? So then I can use 63 as my common denominator. So we're going to multiply everything in this equation by 63. You can either do it the first way I told you, like this, or you can just multiply straight across, or I can show you how to do it calculator. So let's do this. Let's talk about the calculator. Can we put variables in our calculator? What number's in front of that X? A 1. Okay. So what we can do is, for a lot of these, is we can use the calculator to multiply the fractions and just keep the variables where they belong. Okay. So what I would do in this case, in my calculator, I'm going to write down your keystrokes. If you're using a calculator like mine. Now these graphing calculators, you have to enter it a little bit differently. But what you would want to do is you would want to hit 63, and then you want to hit times. And what we're going to do is we're going to enter this fraction without the X, and then whatever we get, we'll just put an X on it. Okay. And so to enter the fraction 1 over 7, we're going to hit 1, and then on most calculators, you're going to have a fraction key that looks like that. It's like the second one on the second row, I think, on my calculators. And what happens is when you do that, it's going to be 63, and it turns it like to a little backwards L in your screen. And then you're going to hit that denominator, 7, and then you're going to hit equals. Okay? Or we can say, how many times is 7 divided into 63? And 9 times X is just 9X. When you do 63 times 1 over 7, you get 9 in the calculator, right? Just make sure you stick that X on it. Or if that confuses you, we can always do it regular old multiplication of fractions, where we go straight across. 63X over 7 reduces to be 9X. That makes sense? Well, I'm showing you a bunch of different options so you can decide which one you like the best. That's on you. Don't ever say you have to do it exactly like I show you. I'm going to try to give you as many options as I can. Then I need to take that 63 and multiply it by 2X over 63. And in that case, what's going to happen? The 63's do what? Cancel, and I'm just left with the 2X. And then 63 times 4, I can't forget about that 4. It's not a fraction. It's not going to make a fraction disappear because it's not even a fraction. But 63 times 4 is 252. Okay. And now we have a regular equation, no more fractions that I can continue to solve. I'm going to subtract my 2X over. And we're going to divide, and we end up with, I saw a couple people with this on their paper, what? 36, yeah. Okay. So we kind of get the idea? Sort of, somewhat. Okay. Try 3 and 4 then. You're not sure if you want to know I'll do the fractions in the calculator, and it's not one of mine, and it works a little different. I can show you. Just let me know. I'll be glad to help. We'll fix it for you. All right, what's number 3? My denominators are 3 and 24. What would my common be? 24. So I'm going to multiply everything in this equation by 24. So 24 times 1/3 p is going to give me 8p. 24 times 3 is 72. And then 24 times 1/24p is just p, 1p, right? Don't forget the variable that's out there, especially when it reduces to be just 1. Make sure you, if the variable's there, you stick it in the end. Also, that was a negative 1/24p, so it's going to be a negative 1p. Then I can continue to solve by adding this p over to this one. That gives me 9p equals 72. I divide by 9, and so therefore p is going to be 8. Ooh, not a b, a p. Try that one more time. which I think I saw everybody had P was 8. A couple people were still working on 4, but I did see the 8 there. Is everybody okay with that one? All right, and then for number 4, I actually have 3 denominators, so I need to make sure I'm using the correct number. I have 3, I have 42, and I have 7. I, again, always start with the biggest one. Okay, 42. Does 3 divide into 42? Yes. Does 7 divide into 42? Yes. So then guess what I can use? 42. So, multiplying here. Again, there are a bunch of different ways you can do that. The way that I do it without having to look at a calculator, which sometimes I still have to do a calculator because I can't do it in my head, but I take the denominator. 3 goes into 42 how many times? 14. And 14 times 5 gives me, what did you end up with there? 70, okay? Or you can just do 42 times the fraction 5 over 3 in the calculator and it will tell you 70, right? Okay. Don't forget the y that's with it though. Then I'm going to multiply 42 times 2y. Don't forget the y. 42 times 2, there is no fraction, so that's just going to be 84y. Then we multiply 42 times y over 42. A lot of people put 1, but it's 1 what? 1y. There was a variable there. We can't lose it. We did not make it disappear. And then we're going to do the fraction 5 over 7. Again, if you're not comfortable with those, do it in the calculator. 42 times 5 over 7. The way I think about it, 7 divides into 42 6 times. 6 times 5 is 30. Okay, so 42 times 5 over 7 is 30. I have some y's to combine on the left. That's going to give me a negative 14y. And then I can continue to solve here by subtracting that y. Negative 14 and negative 1 is a negative 15. And then I can divide. And we end up with y equaling negative 2. Perfect. Whoa. Is everybody okay with that one? We're going to skip number 5, and I want to do number 6. It's a little bit more difficult, so we're going to work through it together. I'm going to move it. You can just call it number 5, write it down, and then we'll start talking about how to work through it, okay? So we're going to skip 5 because I want to make sure we have plenty of time to do this, but you can call it 5. So before we get started, I want to just kind of look at it and see if we can tell why this one is slightly different than anything we've done so far. I have multiple fractions, which is okay because we've had multiple fractions in the other ones. I have 3 different denominators, which we've had in the last couple of questions. What else is different? The numerators, what's different about my numerators? They have 2 terms in them, right? So every numerator that we've had so far in questions 1, 2, 3, and 4 has only had 1 term in them. So it was easy to multiply. When we have numerators that have multiple terms, like something plus or minus something else, we have to be extremely careful. All right, so let's start with the common denominator thing. And we did some small numbers this time to make it a little easier. If my numbers are 3, 2, and 6, what's my common denominator? 6. All right, so let's take and multiply everything by 6. The problem is these numerators include binomials with variables that I can't do in the calculator, right? So we have to be careful with this. Is everybody ready? I'm going to start with the first fraction, and here's what I want you to look at. This is what we're thinking of. How many times does 3 divide into 6? 2. Okay, so if I take 6 and divide it by 3, I'm going to have 2. Oh, come on. I'm going to have 2 left over, right? But that 2 has to get multiplied by the entire numerator. What is the entire numerator there? X minus 3. So what should I put that X minus 3 in? Parentheses, yeah. Okay. And the reason I am doing this is because my numerators have binomials, 2 terms. I have to make sure I multiply the leftovers by both terms. Does that make a little sense? Yes. So what I did was, if I do my fraction, what I did is I said 3 goes into 6. How many times? 2. So I changed that to a 2, and that disappeared. And so now it's going to be 2 times all of that. That's why I use parentheses. Okay. Does that make a little bit of sense? Mm-hmm. What comes next? Before the next fraction, what's next? Yeah, I'm going to in a minute. What's after that first fraction? A subtraction sign. So I'm going to go ahead and bring that down. And then I'm going to do the same process again. But this time I want to know how many times does 2 divide into 6? 3. Okay. So I'm going to put 3, but then that 3 has to get multiplied by x minus 4. So I'm going to put those in parentheses again. One divides into that. That 3 has to get multiplied by that. That's why we have the parentheses there. Everybody kind of following along a little bit? Then I have an equal sign, so I'm going to bring that down. And I'm going to take and multiply 6 by what? 1, which just gives me 6. What's next? CJ? I left it just in front of the 3, so that when I distribute it, it'll be distributed as a -3. This is just like individualizing one little part of it. Bring down the subtraction sign, yep. And then we're going to take 6 and multiply it by this fraction. 6 divided by 6 is what? 1, but what kind of 1 are we going to have to distribute? That -1. So I'm going to put that there and put the 2 minus 6 in parentheses. Otherwise, I'm going to forget to distribute that negative, and I'm going to make a mistake there. So anytime you have subtraction and binomials in the top, we want to be very careful. It's probably best to write it with all these parentheses so that you don't forget to distribute everything. Does everybody kind of understand where all of that came from? All right, let's distribute now. Start at the beginning. We're going to go 2 times x. We're going to go 2 times -3. And then what kind of 3 am I going to distribute? A -3. Quick question. Should I do 6 minus 1 first? No. Multiplication comes before subtraction, right? So we're going to keep that 6, and we're going to distribute that -1 to those parentheses, or to that parenthesis. Keep going. Combine your terms. Finish solving this thing. A little bit more difficult because we have binomials in the numerators. We also have negative signs, so we need to be very, very careful with this as we're working through it. I know there are some of you that can probably do a lot of this in your head, and that is okay. I'm showing every step for those people who can't do this in their head, and that is perfectly okay as well. Sometimes if you try to keep too much in your head, you're going to get confused. Combining my like terms before I begin. What'd you guys get? I got positive 6. Did you make sure up here in this part that you distributed that negative and that made that a positive 6, which would then make that a positive 6 and is a 12? Is everybody okay with 6? Kind of understand? I'll come look at your paper in a second.